Hello and welcome to Built Environment Matters, a monthly podcast brought to you by Bryden Wood, an international company of technologists, designers, architects, engineers and analysts working for a better built environment. Bryden Wood believe in design to value, to cut carbon, drive efficiency, save time, make beautiful places and build a better future.
Hello and welcome to Built Environment Matters. I'm Alison Zack-Collins and I'll be your host for this episode. I'm joined by Jaimie Johnston, Director and Head of Global Systems at Bryden Wood. Jaimie was Bryden Wood's first employee when Mark Bryden and Martin Wood set up the practice back in 1995. He's now recognised as one of the UK's leading thinkers on the future of industrialised construction. In addition to his role here, he's also the design lead for the Construction Innovation Hub, a body funded by the UK government whose aim is to transform construction. So Jaimie, thanks for joining us. What are you going to talk about today?
Hi there. Yeah, it's great to be here and I'm really looking forward to talking to you about construction platforms.
Great. First things first, what are platforms?
So platforms is a term that gets used in other industries, particularly manufacturing, and it refers to sets of components or assemblies that can be put together in lots of different ways to make lots of different products. So probably the most obvious example, or the one that most people are familiar with, is in automotive. You can obviously get a very large degree of customization of your vehicle, but it uses the same components and standard manufacturing processes to create lots of different versions of the same model. So BMW, Volkswagen use the same chassis for every car, and the thing that makes it different is then the engine, the wheels, the trim, etc., etc. Another good example that we often use is IKEA, because it's a much closer to home example. So probably most people have got experience of making IKEA furniture, and actually it doesn't matter whether you're making a wardrobe or a bed or a chest of drawers or a bookshelf. Most of the connecting pieces are exactly the same and the processes used to put the bits together are the same, and it's the bit that make the shelves or the bed slats that are different. So IKEA is able to make a whole range of different pieces of furniture using actually quite a limited kit of components. And so again, what we're trying to do with construction platforms is apply the same thinking to the building of our assets.
Great. So more specifically, how do you apply that principle to construction?
What we noticed actually is that there's a huge commonality between lots of sector types. So for instance, floor-to-floor heights are a person height plus headroom plus a zone then for structures and mechanical electrical systems, architectural finishes. So lots of buildings have a very similar floor-to-floor height, and that's all to do with the size of people and nothing to do with sector. But at that floor-to-floor height, you can get natural light about 8 metres into a building, and that's why schools and apartment buildings and wards in healthcare and certain office types have a sort of 8 metre span, corridor 8 metre span. So platforms or construction platforms was an attempt to identify those commonalities and use that to derive a common kit of parts that would allow you to build lots of different sector types using effectively the same components. And that's how you start getting into the economies of scale that manufacturing likes, and that's how you start to be able to apply manufacturing techniques and processes. So platforms was our attempt to identify that kit of parts and drive construction from being a very trade-based, sector-based way of working into something that's much more like manufacturing with those economies of scale and all the benefits that manufacturing's seen.
That's really interesting. And can you tell us why it's so critical we adopt this approach?
The reason this is so critical, everyone, I think it's been well documented over the last several years now that construction's in something of a crisis. So we're facing an ageing demographic in the workforce, not enough young people coming into construction to top up those numbers, chronically low productivity, chronically bad value for money. And those problems are only going to get exacerbated as the world becomes more focused on materials and resource efficiency. And then UN predicts another 4.5 billion people are on the way. So world population is predicted to top out at about 11.5 billion. So that means we have to provide very good quality healthcare, education, housing, social and transport infrastructure for another 4 billion people. At the same time, it's been documented that construction contributes about 40% of carbon emissions. So we're now faced with an unprecedented situation, or a much exacerbated situation, where our capability to build things is reasonably poor. The need to build things is getting exponentially greater, and the pressure on climate emergency, etc., means that we have to do things in a fundamentally different way. So, construction's had thousands of years to incrementally improve itself with very, very little impact. We believe if we don't fundamentally change the way we design and build our assets, we haven't possibly got a chance of keeping up with the needs of society, and the result will be disastrous. We will be able to build not enough infrastructure, it'll be poor quality infrastructure, it'll contribute or accelerate global warming, and we'll actually get ourselves into a worse situation. So we believe actually it's not just a case that platforms may help us resolve some of these issues. We actually think if we don't do something like this, then humanity is facing a terrible crisis, and construction is going to play a disproportionate role in either helping resolve that or accelerating humanity's demise at a certain level. So the stakes are enormously high, and so we think there should be a enormous interest in this topic.
Yeah, definitely. There really should be. Now, can you clarify, are platforms the same as design for manufacture and assembly or other modern methods of construction?
There are a whole array of terms that are bandied about, certainly in the press and at conferences and things at the moment, and they're often used interchangeably. So people talk about modern methods of construction, design for manufacture and assembly, industrialised construction, P-DfMA, volumetric modular, and all of those terms get used, as I say, relatively interchangeably. We're doing some work, or the Construction Innovation Hub, of which I'm the design lead, has been doing some work to create a lexicon for people to help clarify those terms. In my mind, modern methods of construction is an overarching term, and it applies to all forms of innovation in construction. So it's not just the physical forms, but it also covers use of virtual reality, augmented reality, robotics, automation in construction, use of point cloud surveys, data, algorithmic design. So in my mind, modern methods of construction describes a whole range of tools, techniques, and physical outcomes of how we design and build our assets. Within that, design for manufacture and assembly, people often use to describe the product. So people often use DfMA as a shorthand for, say, volumetric modular, so 3D modules turning up. We like the term DfMA because it describes the process. So it's design for manufacture and assembly. And that, for us, is a critical part of this. If you want to manufacture and assemble buildings or assets, you need to design them towards that process. One of the blockers that we perceive, or one of the reasons I think people have struggled to do this at scale, is that too often people do a traditional design process and at a late stage try and retrofit some form of DfMA. So they try to modularize the building or panelize the building or apply some form of DfMA. And what they find is either you end up compromising the design to make it fit the system, or you end up having an inefficient system that's not working at its optimum to make the building work. So we think that D part is absolutely critical, that you have to start with that manufacturing assembly process in mind, and it has to drive the way you design the asset, the way you engage the client, the way you engage the supply chain, so it changes the entire process. And I think that's why it's a problem, because not many people necessarily have the capability or the skills to see that process end to end. There's another aspect of that which Bryden Wood is to some extent a reaction to. When I was at college, the idea of the architect as master builder, or the sort of driving force behind a project, was still prevalent. And what we've seen even in the time since I started work professionally is that the industry has sort of atomized itself into very deep but narrow specialisms. So, for instance, we see on projects where you have a master planning architect, executive architect, concept architect, facade architect, interiors architect. So even the architecture role has been split into lots of different specialisms. The result of that is that you need now a very, very large team of lots of different specialisms to work on a project. And the result of that is that people are only seeing a tiny bit of the project often only for one or two of the work stages. And so people are looking at a tiny fraction of the project. They're sort of doing what they can to protect their piece of the work. And what we've lost is that sort of overarching person that understands the project start to finish. And you can imagine that innovation doesn't respect discipline boundaries or sector boundaries or stage boundaries. If you wanted to do something different, it has to sit across the entire process. So that's why Bryden Wood has as many disciplines as it does. It's why it's sort of grown its capabilities from the traditional design disciplines into also having product designers and industrial designers and chemists and data analysts and coders and process engineers, because we recognise that to completely integrate, coordinate, rationalise that design, you need to understand the complete process end to end. So we've spent a long time building up those capabilities, but as I say, the industry isn't geared towards doing that, and I think that's one of the big cultural blockers that has prevented us from doing this at scale. The other aspect of this we find difficult to overcome is that people have latched onto this word off-site. So the thing that often gets quoted is the autumn statement 2017 that said, included the phrase presumption in favour of off-site. So if off-site was your success criteria, that would drive you to be building factories, to be making large modules in factories, to be moving everything off-site. If you go back to the original text, that's not quite what the government said. The actual text said government wants to improve the timeliness, cost effectiveness and productivity in the delivery of its assets. It will use its spending power to promote modern methods of construction such as off-site. So what they were really saying was we want to improve the outcomes by changing the process using modern methods of construction, which, as I said, includes lots of different aspects. And even then they said such as off-site. So off-site was one aspect of it. In my head, there's been quite a lot of focus on driving everything off-site. And it's certainly part of the solution. It's certainly part of the mix of solutions we need, but it's not the only one. So platforms was an attempt to look more deeply at that. How do you change the process? How do you increase productivity and timeliness and cost effectiveness? What would that look like? So rather than try and put things off-site necessarily, we've been focusing on saying, so what's the least amount of material I could possibly need to build an asset? How few times can it be touched or processed? By how few people, and how productive can you make those people? So we're just trying to, again, it's a very manufacturing principle, strip out anything that's non-value adding and work out what is the leanest possible way we can deliver assets. And it doesn't necessarily drive you off-site, but it does change the way you think about the way you manage materials and people, etc., etc.
Yeah, that really makes sense. So what are the benefits of platforms?
So we're already seeing a huge range of benefits in all sorts of areas. So for clients, some of the key ones, we have a project on site for Landsec at the moment. It's a commercial office building in London. The numbers they're reporting back is an increase by a few % of net lettable area. And if you're Landsec and your business is all about net lettable area, then that's an enormous business benefit. We're seeing much better safety because of the reduction of work at height, for instance, and we're seeing overall we anticipate about a third fewer operatives on site. For particular packages, particularly the superstructure, we're looking at about a 50% reduction in people on site. And that's because of we're applying automation in construction. So we're starting to see what type and what level of automation is appropriate on construction. So we'll come back to that. They're also reporting lower capital cost. Because of the optimization we can put into the components, we're seeing about 25% less material overall. We've got about 40% less steel in the building and overall about 20% less embodied carbon and about 13% quicker. So if it was a standalone project, those metrics of lower capital cost, quicker, fewer people, less embodied material, and more net lettable area would stack up. It would make it immediately a sensible thing to do. Actually, this is the first project that Landsec are doing. It's the first real platforms project in that sense. So we're expecting those metrics over time to get better and better. But as I say, for the first project we're doing, to have achieved those metrics is fantastic, and we're expecting that to get better. The other one of the things that drove us to create these in the first place was working with government. So Ministry of Justice had some analysis done. They were the first department to adopt BIM. They were driving lean very hard. And what they found was, after some analysis across their projects, about 50% of every pound they spent ended up as residual asset value, so ended up in the building. About 50% of it disappeared. So some of that was into positive things like profit in the supply chain. The majority of that was in waste, in rework, in transactional cost, in the kind of layering of the supply chain. So a lot of it was not really value adding. And as everyone's seen the statistics, profit in construction is not massive. So it's not even as though the big players were making vast sums of money doing this. It's just a very inefficient way of building. So I talked earlier about trying to get back to asset value. So the other thing MOJ were finding is the things that were causing most of the problems on their projects were poor productivity, labour shortage, lack of materials, and lack of design information. So those are really simple things to fix. So what we've been trying to do with platforms is, because you have limited numbers of components, you can then limit the number of operations that happen on site, the number of processes. That means you can control them much better. You can control your materials much more accurately, and we put a lot of effort into optimizing every component. So you can imagine, if you're going to make a component 1,000,000 times, every gram of material you take out, every manufacturing process, every assembly process has a massive multiplier effect. So on traditional construction, where every building is a prototype, it never warrants that level of focus on the design of every component. One thing platforms does is allows us to put tons of effort into each component, because we know we're going to use it again and again and again. So straight away, that helps us reduce the amount of material, which I've talked about. It also opens up the door to a whole range of other things. So I talked about automation and construction. Given that we have fewer processes that are very highly repeatable, you can then start to say, well, now how can I take that process and can I apply some level of automation to it? So we're looking at, in the manufacture of the components, robotic welding, for instance, to make the bits. On site, we're looking at using equipment which is really common in distribution warehouses, Amazon sheds all around the world, to lift and place components, which means we're using far fewer people, working much more safely, working much more productively. And we were doing it for those reasons, but in a post-COVID world where there will be a need to control numbers of people on site, make sure they're socially distanced, make sure activity is much more controlled, it suddenly is a massive benefit for those things moving forward. So for constructors, it will change the nature of the supply chain. So I mentioned earlier that a big chunk of the cost of an asset is the hierarchy. It's the transactional cost. So tier one takes the project, splits it up into a series of packages, pushes that down through the supply chain with the risk, and it goes all the way down through the tiers. That's where a lot of that inefficiency happens. What happens in manufacturing is the customer, or the OEM, is much closer to their supply chain. They have a much more direct relationship with their supply chain. And it's what we're starting to see on, for instance, on the Landsec project. We're now dealing much more directly with the aggregate industries on the concrete. We're talking to the steel fabricators much more directly. We're talking to the facade manufacturers and installers much more directly. So what it's doing is bringing the client much closer to their supply chain and allowing us to unlock loads of benefit. So a good example, because the superstructure for the Landsec project has been designed in such a way that it's very, very accurate. So again, because we're manufacturing the components, we're getting a very high levels of accuracy. There's lots of people in the facade supply chain who can already make you a millimetre perfect unitized cladding system, but they spend a lot of their time fixing the gaps between their millimetre perfect manufactured product and your traditionally built superstructure that sits behind it. What we found on the Landsec project is, because the superstructure is super accurate and we can design in all the fixing points, we're getting a sort of 30-40% reduction in the facade cost, simply because they believe that on site they'll be much more productive. They'll spend a lot less time filling in the gaps. And so we're not changing the design of the facade, but we're unlocking sort of latent innovation or latent capability that you couldn't normally get your hands on because those people are too far from the client. So what we're doing is closing those gaps, allowing much richer conversations between the client and the supply chain, and therefore cutting out a lot of that kind of transactional stuff in the middle. So for Landsec, we're actually, we've got two of the main contractors, but rather than acting as contractors, they're acting as what we call the manufacturing assembly manager. So their job is to set up the site, control the logistics, manage the contracts for the client, but it's much more of almost like a consultancy role than it is a tier one role. So it's a more profitable, more sophisticated role, and we think that's where some of this will end up, that the tier ones will put more effort into controlling logistics and supply chain and those sorts of things, and they will the kind of traditional role. So there's big shifts coming, and it will change everyone's role through the supply chain, but for greater benefit. People should spend more time doing the thing that's most value adding and less of the kind of bulk lifting and moving things around.
Great. And thinking about architects, how will they benefit specifically?
There's a slide we often use that says that the idea that the architect has is maybe 90% of the value they add, but it's only 10% of the effort. Most of an architect's effort or other designer's effort at the moment goes into documenting the idea. So creating the drawings, creating the schedules, creating all the the material that's needed to actually describe the idea. So we think what will happen is that once you start thinking of buildings not as being designed from first principles, but as configurations of components, architects can spend more time having more ideas. So the real value you add is in the placemaking, it's the aspect, it's the prospect, it's the massing of the building on the site. So what we think will happen is architects can spend more time, testing ideas and coming up with better designs, because once you have a design that you're happy with, the standardization of the components and the digital stuff that unlocks allows you to document the idea very quickly. So to give you an example, because we're using standardized components, we can then document the rules around those components. It means we can automate the design process to a certain level, or certainly automate the production of the BIM model. So we have an app called Prism, which is a housing design app. It allows you to design a housing feasibility on a site very, very quickly. So you can literally in 20 minutes create yourself a kind of feasibility massing study. We can take that model and then we can apply or put it into simulation software, so we can test vertical sky components, we can look at overshadowing, pedestrian movements, place making, views, etc., etc. So you can do lots of simulation and test your proposed designs to a much greater level of detail than you would necessarily have been able to do previously. Once you've got a design that you think is the absolute optimum design for that site, you then tell the model to go off and get the components it needs. So because every space knows all of the mechanical, electrical components, the wall types, the doors, it knows the structural components, it can go and generate a LOD 400 bill of materials quality BIM model in 20 minutes. So the speed with which you can get to a very, very highly integrated model is incredibly quick now. So we use some of that speed as benefit. So some of it goes back to the client as a quicker outcome. We actually use a lot of that to test more ideas and try more potential solutions on a site. So the benefits to architects, it allows them to spend more time on the bit that they train to do. They can spend more time on the value-adding, creatively challenging, interesting bits, and less on the kind of grunt work of having to document the building. So there's obviously question people ask about, does that mean we're doing people out of jobs? Does that mean we're going to reduce the need for designers? Again, if you go back to some of those earlier comments about the amount of infrastructure we need to build. So every year we don't build 200,000 homes that we're supposed to. We don't build enough schools, road, rail around the world. So it's not a question of doing people out of jobs. It's allowing people to to possibly have a chance of keeping up with the needs of the world. So there's so much stuff needs designing. We need to find a way to improve the bandwidth of our design community. So we think if we don't apply these tools, that will be the death of good design, because there simply won't be enough people to design enough high quality infrastructure. The other interest of ours is that there's not enough, or construction's not viewed as being a particularly interesting sector to young people. They'd much rather go and work in something groovy like tech than come into construction, which, perception is it's, standing in muddy boots on a filthy field trying to build things in the rain. There's a whole generation of Minecraft players and gamers who actually have a lot of the skills that we're after. They work collaboratively, they build things in a 3D environment, they use standardized components, they work well together. They actually have all the skill sets that we're describing in the future, but if we don't make it obvious to them that construction is a place where they can apply those skills, they won't come into construction, they'll go and work for a big tech company. So we think there's a really vital part here in proving how this sort of technology suddenly makes construction much more interesting to digital natives who, if they came into a sector that didn't have that tech about it, they just wouldn't be interested. So we did a schools design app called Seismic that allows you to design a code compliant school very, very quickly. So we've digitized all of the space standards, we've created a digital library of components, and you plug in a few metrics, it gives you your digital Lego pack of parts, and then you just configure them on a site. And we tested that on a team of 9-year-olds in a primary school in Hackney. And actually the speed with which 9-year-olds who play Minecraft picked it up was incredible, and they had no fear. They automatically knew how to use it. They were very, very intuitive users of it, and they created designs which maybe a traditional designer wouldn't have come up with. So as well as providing these tools that allow architects to do their job quicker and better, the ability to engage more people in the design process, democratise the design process. So the headmaster made a comment that normally he's the recipient of, at the end of this, when the thing's been designed and built, it gets handed over and he has to work out how to use it. The idea that he could engage in the design, understand those design rules, understand why schools are designed the way they are, he thought was incredibly interesting. And the children were very excited and saying, we should do more of these. We should have one for housing, for healthcare, so we think that's where that's going to head, that more and more of those building types that can be described by base standards, technical standards, rule sets, are right for some form of algorithmic design, which will allow you to design much better things much quicker to a much higher quality, and feed that digital process all the way through manufacturing, assembly, automation and construction and onto site.
Fantastic, that sounds great. And what about society as a whole? How will we all benefit from the adoption of platforms?
So the benefits for overall society, as I've said, I think the need to build vast amounts of infrastructure is, I think we haven't quite understood the implications of that yet. But yeah, we need to build enormous amounts of social and transport infrastructure around the world. So as I say, I think if we don't apply these techniques, we can't possibly keep up with those needs. You can imagine population growth coupled with the infrastructure it needs is going to massively accelerate the amount of carbon we generate. So we need to find ways to deliver this infrastructure using much, much, much less carbon. So all of the things I've described, the optimization of materials, the application of automation, better control of logistics, fewer people on site, all of that is contributing to an overall lower carbon version of the built environment. So the Landsec project, it's their first net carbon zero building. We've got 20% less embodied carbon in that building. We're now working very hard with some of the concrete manufacturers to look at what is the lowest carbon form of concrete we can possibly use. We're talking to the steel manufacturers about the types of steel that will be made by electric arc furnaces powered by hydrogen fuel cells. So we're working very hard to work out what is the lowest carbon form of construction. Timber is obviously in that mix, and it will certainly form an important part of our construction moving forwards, but I don't think anyone knows the answer to some of the questions surrounding timber. So for instance, is it viable to grow enough forest to build enough buildings using timber? My suspicion is probably not. There's obviously certain parts of the world where cross-laminated timber is widely available and probably is a very good solution. There's parts of the world where clearly it isn't, because the transport costs of moving a big heavy material onto site that probably offsets the amount of carbon you're storing. And once a timber building is a timber building, it can never be anything else, because if the timber rots or gets burned, it releases all that carbon. So the sequestration of carbon is another open question. So yeah, we don't know. I don't think anyone knows the answer to all of these. It's an incredibly complex topic. What we're trying to do is contribute to the debate by saying, well, we think there's certainly a place for steel and concrete moving forwards. If that's true, what's the lowest carbon form of that we can possibly have? Because we think the answer will be a mix of low carbon concrete, low carbon steel, CLT, timber, composites, probably some other materials that are coming out. But we have to start trying to force these things forward now. There is, for instance, geopolymer concretes, which are a very low carbon form of concrete, have been around for decades, but they've been traditionally far too expensive. Our guess is that as more and more people focus on this, the market will drive the price down. There'll be a greater need for it. So this isn't a new technology. It's a technology that's been around, but it's been out of reach for a long time. So I think there's things like that will suddenly start to come to the fore. And again, it's just going to increase the kind of mix of materials available to us, with the end state that everyone should be saying, how do we make a planet that sustainably supports 11.5 billion people? That's the problem statement facing humanity, and everyone should be doing what they can to enrich that conversation or to contribute to that debate.
Absolutely, they should. So tell us, how do the benefits of platforms compare with other modern methods of construction?
Bryden Wood was set up 25 years ago, and we initially had an interest in design for manufacture and assembly. It's the phrase that Martin Wood often used, was that he wanted to be an architect, but not in this industry, which meant helping reshape the industry, which seemed like a very naive, brave thing to say when there were just a few of us, but actually we're starting to get some inroads. So we thought that DfMA was going to be the big shift that changed in the industry. It's been a much longer time coming, I think, than we'd predicted. Part of that is we needed to get the hang of BIM. So I think actually, in retrospect, there's a number of steps that had to occur before we could get anywhere close to this. So BIM was needed to get a kind of level of digitisation in the industry on which we could build. BIM was never intended as the end state. It was an enabler of other things that would follow. The other aspect, I think we've developed lots of different DfMA systems for lots of different clients. What we found is that client value drivers need lots of different versions of DfMA. So I'll give you an example. Some clients are all about speed. So Heathrow, for instance, their biggest driver is fewest number of people on site and quickest delivery of a thing. And that drives you towards more often not volumetric modular, because you want to have the absolute least number of people on site, particularly airside, because the business benefit to them of not having a stand closed or getting passengers through a new building is absolutely vast. And so speed is probably their number one driver. Someone like GlaxoSmithKline would take certainty over speed. So to put that in context, they've got a new drug that they want to start manufacturing. By the time they've gone through all the approvals, they want to be manufacturing the drug on the day they get the approvals, because they get a limited period in which to manufacture the drug at scale before generics kick in. So actually having a building too quick doesn't help them, because if they get the building quicker and it's sitting there empty, that's no use to them. Getting a building late is disastrous, because they're losing that window where they could be manufacturing the drug. And we've certainly worked on projects where that would have meant people dying because people weren't getting life-saving or life-extending drugs. So they're much more interested in certainty and the building being delivered when they said it would be than anything else. If they had speed, so often we've designed systems for Glaxo that allow you to build buildings quicker. What it means is they will delay the capital decision. So they want to be able to spend that money as late in the process as possible, when it's looking as likely as possible they'll get all the approvals. So they would take that speed benefit, and where Heathrow would open the building quicker, Glaxo would start the building later. So there's all these nuances around client drivers to do with cost, time, net present value, capital decisions or funding decisions. And it means there's lots of different versions of DfMA that are appropriate. Platforms is our attempt to take all of that learning, all of the best of those, and embody them in one single kind of ecosystem of components. So platforms, I suppose, is the culmination of everything we've learnt in various forms of DfMA. So we've been very lucky that we've had big clients like Heathrow, like Circle, like GSK, that have allowed us to develop these systems. We have a sort of deal with our clients where we say to every client that you're going to benefit from everything we've done for previous clients, but the next client will benefit from the things we're doing with you. So we're on a journey, or you're joining us on this journey, and over time we're evolving systems which are more and more adaptable and more generalized. And platforms is our attempt to take all of that learning, all of that benefit from every other client, and sort of embed it in a set of components that the industry can more generally benefit from. So it's I've talked about some of the the things we've been doing in focusing on least amount of material, lowest carbon material, highest productivity, most general application. So we're trying to get platforms to be the embodiment of everything we've learned over 25 years on this journey. And the statistics we're getting are starting to prove that. The fact that UK government, IPA, particularly Infrastructure Projects Authority, has articulating their vision of platforms. They've put money into the Construction Innovation Hub, and that's starting to get some real traction. That's starting to become a movement that the industry can join us on. We're starting to get some real benefits now. So obviously, the more people do this, the greater the economies of scale, the greater the benefits. The more people are able to engage with the platforms program, join us on this journey. We think it's got the best chance of becoming a kind of widely scalable, widely adoptable system. Another analogy I sometimes use is that not many people know how to design a car and build a car from scratch, but loads of people know how to drive a car. So I talked earlier about there being this sort of gap that lots of people don't know how to design for manufacture and assembly. By trying to embed everything we've learned and all this best practice in a small number of components, hopefully then loads of people could build things with them, design with them. So just like you don't have to know much about furniture to make an IKEA wardrobe, you wouldn't necessarily need to know why the components are designed like they are, or how they evolved, or where they arose from. If you know they're good quality, they create high productivity, they're good from a carbon perspective, brilliant. Lots of people can pick them up. So again, it's our way of trying to create a physical kit of components and the kind of digital workflows that support them that becomes very, very scalable, potentially very quickly. And certainly with government support, if they continue to drive it through their pipeline, this could be our tipping point. And every other sector is seeing these kind of network effects where Amazon or Netflix or Google or Airbnb suddenly transform sectors very quickly. We're hopeful that platforms could become that network effect. More and more people join it, more and more people get the benefit. It becomes much more prevalent, and that's the thing that really allows everyone to transform the sector.
Right, okay. Can you explain in more detail how platforms delivers these benefits?
So I've talked about the benefits in terms of less material, fewer people, higher productivity. That's driving cost benefits. Particularly what we're seeing on some of the evidence so far is that you could build, say, a superstructure with half the number of people in half the time. So that's a kind of fourfold increase in productivity, whilst using significantly less material. So we're looking at 25% less material overall, 20% less embodied carbon. So I think there's enormous benefits there just in terms of time, cost, productivity. The maybe slightly less tangible ones are, I've talked about if we were manufacturing components, you're suddenly talking about manufacturing like tolerances. So whereas in a superstructure, you might be looking at 5 or 10 mil deflection or 5 or 10 mil tolerance, we're down in the kind of low numbers of millimeters. We've done projects for delivery of Crossrail tunnel lining was literally zero tolerance. We'd designed ways to take out all the tolerance, so we were down at literally zero tolerance. So instantly that unlocks a whole load of things around better quality buildings, more airtight, better performing. So there's some benefits there. Yeah, so that instantly increases the quality of buildings. So you can imagine when you've got much higher quality components, you can make buildings which are much more weather tight, airtight, and therefore you can control the internal environment. So that has impacts on the overall performance of the building, the energy use of the building. We're also using that repetition to integrate things much more closely. So, give an example, in lots of building types, hospitals particularly, above the ceiling void, you have a zone for pipe work and for duct work and for cable trays and electrics and lighting and architectural finishes and structure. So you end up with these large ceiling voids. All of the air in that void needs to be heated and treated. So you end up with a building that has a greater volume than it needs to. If you look under your car bonnet, like, there's no wasted space. Everything has been incredibly well integrated and turned into a product. So again, that use of standardization or the time we have to design these things means that we do a much tighter job of integrating and rationalizing mechanical electrical systems, compressing them into much smaller, much more integrated products. And we're seeing, we've had projects where we could literally take 30-40% of the building volume out simply by doing a better job of integrating the design. And once you get into that space, then obviously the building gets smaller, and therefore the air handling plant gets smaller, and therefore the running cost gets smaller. You need less energy, less lighting. So there's a virtuous circle of benefit that comes. We describe it as a chain reaction that once I've integrated the design, the building gets smaller and it unravels, smaller plant, all the rest of it. So there's a impact there in terms of operational cost. And I've touched on this, the use of standard processes and standard components means we can automate the design, so we can now apply much greater levels of digital sophistication in the design process, linked then to use of automation on site. So again, once you get into that standard set of components, the benefits are not just in the time and the cost, but it's in the quality, it's in the automation, it's in the productivity and design, it's in the assembly process, manufacturing process. So yeah, the sort of the benefits spread out across all aspects of the design and construction, right through into operation. My guess is that where we could end up is that we build what I would describe as loose fit superstructures. So most of the embodied carbon goes into the superstructure. So my guess is you could end up designing the superstructure for 100-year life, and the first configuration, it's an office block. The second configuration, you can pop out all of those components and refit it as a residential building or as a school or something else. So my guess is we'll build superstructures on a permanent basis, and we'll think of the facade as a configuration of components that might change on a 20-30 year life cycle. The interior fit out might change on a 5-10 year life cycle. Because they're standardized components at end of life, all of them will be designed to be reused or redeployed or recycled. So you'll get into circular economy, and we'll start to think of buildings less as big fixed assets and more as flexible configurations that can change over time. And yeah, straight away that will give us a load of future flexibility. It will start to change how we think about the permanence of buildings. And my guess is that as buildings become smarter, so as we get more and more IoT connected devices and we start to build up the data set you need for machine learning, say, buildings could start to become self-optimizing. So they could start to recognize how air change or lighting levels or whatever it is needs to change over a day to create the most healthy, productive spaces. Buildings could start to recognize which configurations of components create the best working environments. So we could get to a point where that feeds back into the design process. Our buildings become much more self-optimizing and kind of self-flexing around us to create the best possible working conditions. So I think that's a really exciting space that we'll stop thinking of the traditional fixed design process and start thinking much more about a open-ended process of continual improvement in our buildings, all of which will feed into the next generation of components. So I think there's some really exciting ways of working that this could unlock if we choose to let it, or if we design towards that.
Great, that sounds really exciting. But does using platforms mean that every building will look the same?
So no, it's been a critical golden rule of ours since we started that you never let the design of an asset be compromised by the system. So you never let, say you have a system that wants to have an 8-metre span, but the client needs an 8.2-metre span for a space. We would never constrain the quality of the design to make the system work. So we've tried very hard to create these flexible kit of parts that allows us to deliver very, very site-specific, content-specific assets for clients while still using completely standard components. And again, going back to the automotive example, there's literally millions of possible combinations of components you can have when you order your car now, but they're all the same components and standard processes. One thing we've perceived is or noticed is that there's a real tension, I think, between the level of standardization you might want to drive a factory and the level of variability that the market wants or sites need or clients need. So volumetric modular, for instance, if you've set up a factory to make volumetric modular, you want every module to be as identical as possible. And that's at odds with the need for specific sites where clients want to obviously maximize the amount of building on a site. So one of our mantras has always been to allow a level of flexibility in the components that means that you can resolve that tension. So to give you an example, for the Platform 2 superstructure, we have a series of standard connection brackets which link the beams and the columns. So you always use the same brackets. They're color coded so that we can train people how to assemble each of those, and they become very quick at doing them. The length of the beam and the length of the column can be actually any length you like. So you can make the spans and the floor-to-floor heights very specific to a particular client, but to the operative on site, it's the yellow bracket. So I have my torque wrench, 2 bolts, and I can put the bits together. So instantly you can get that standardization of components and processes while allowing complete flexibility in terms of spans and floor-to-floor heights, for instance. So again, platforms, by getting down at a much more granular level than the entire system, it allows us to resolve that tension. It also allows for kind of open-ended continual improvement. So currently we use welded brackets. If there was a 3D printing process that made better brackets, we could swap those in, so you can start to change any of the components, which again allows for more variability moving forward in terms of material choices and supply chain choices, etc. The other sort of myth that we often run into, there's a lot of discussion around this sort of, whether we will curtail standardization in service of adopting platforms. Actually, for a lot of our clients, what they want is standardization. So Department for Education knows exactly what the best performing teaching space looks like. They don't want people designing that from scratch each time. Ministry of Justice had at one point 16 different so-called standard cells. Most residential developers have a pattern book of apartments that they want to sell. Because of the way the UK market's set up, apartments aren't sold by area, they're sold by numbers of bedrooms, for instance. So there's no benefit to a resi developer having a slightly bigger flat because they can't sell it for any more money. So actually a lot of our clients want standardization, and it frustrates them when they get slightly different apartment layouts or slightly different classrooms or whatever it is. So for a lot of clients, actually, they would much rather that the layouts and the things like that were standardized. They want the variability and flexibility to be in the massing of the building and in the articulation of the facade, in the articulation of the material choice, those sorts of things. So again, we don't think there's actually a tension between standardization and customization. Most clients are telling us that a level of standardization is incredibly useful because it unlocks things on site, future maintenance, for instance. They would like to have a kind of consistent product, and they're frustrated that they're not getting that. They're getting too much variability where it's not adding benefit. So again, we're very cognizant of that, and we've put a lot of effort into making sure that the platforms we develop have sufficient variability to make sure it covers all those eventualities. But actually, we work very hard with clients at the early stages to set the spans, to set the grids, to set the planning grids, to facilitate a design process which gets the client exactly what they want. while still allowing that kind of variability where it adds the most benefit or where it's architecturally needed, to create places, to create spaces, to create attractive environments, etc.
That's great. I'm really pleased to hear that. And for my final question today, are platforms unique to Bryden Wood, or are they open to other people to use?
No, so we started the first use of the terms platforms came about through work we were doing for the Ministry of Justice. So we were brought in 2016 to design a new type of prison that was focused much more on rehabilitation. So the cycle of reoffending, people come out of prison, can't find work, fall back into their old ways, go back to prison. That cycle costs somewhere between 10 and 12 billion pounds every year. So we were asked by the Ministry of Justice to design a new type of prison that was much more focused on rehabilitation. So the plan at the time was 10,000 spaces, 1.2 billion pounds, 6 sites, and develop a standardised set of buildings that could be placed on a whole series of different sites. And again, they wanted that level of standardisation that you could then put a load of effort into designing absolutely the best environment. So one aspect of that was we designed a new type of prison, which is there's one on site at the moment in Wellingborough. Another aspect of that is we said, look, you could use this to drive the adoption of DfMA at a scale that hasn't been done before by government. So we knew Ministry of Justice very well. We'd worked with them since 2011, initially on BIM and then into digital libraries, then into more advanced digital ways of working. So we said, actually, there's a really interesting thing you could do is design that suite of buildings with a view to having them manufacturable or certain bits manufacturable by prison industries. The benefit of that would be that while you're building the prisons, you could be teaching serving prisoners manufacturing and warehousing and logistics and certain skills, and you could then create a market for them to come out into. So you could use the buildings of the prisons to kickstart the rehabilitative thing that the prisons are there to do. So if you could use it to upskill a generation of inmates and create a market for them to come into, you could actually increase their chances of rehabilitation. So that became a really interesting conversation with government. And it's when the Infrastructure and Projects Authority started to get involved. And the other part of that, we said, look, across the MOJ estate, obviously there's lots and lots of secure accommodation, but it's not dissimilar to student accommodation, really, or single living accommodation for the army. MOJ has a lot of education, and it's not dissimilar to the DFE's teaching spaces. They have healthcare, they have offices, they have warehouses. So we said, look, if we develop these systems and they were good for the Ministry of Justice, they would actually be presumably good for all the other departments. And so you could start to cross-fertilise things we're doing for one government department into the others. So the term platforms came around through a working group that was set up with us, the Ministry of Justice, the IPA and the MTC to start to look at this idea. So it was the MTC Manufacturing Technology Centre that first introduced us to the concept of platforms and said, look, this is how it works in automotive, for instance. That's what we could head towards. So that started that conversation back in 2017. We published our book on platforms, the first book on platforms. That was certainly informative of then the autumn statement, and then that informed into the transforming infrastructure. So I'm really pleased, actually, that it's been an ongoing conversation with government. I'm surprised that more people haven't joined the dots. So you can see from the autumn statement 2017, transforming infrastructure performance, the construction sector deal, then the IPA putting out its document on platforms, launched the same week as the Construction Innovation Hub was announced. There's been a continuing resolution of that idea or increasing levels of granularity and detail around it, but they've stayed on this path and said, look, we're going to do MMC. Eventually said that means platforms. Then they've set up the hub to help do that. So, yeah, I think it's a fantastic good news story that government intervened and mandated BIM, for instance, was the last big shift in the construction sector. They're now using that to drive whatever it means in terms of platforms. So I think that's a really positive thing that's happened. And we've effectively said, or we had written into our contract with the Ministry of Justice, that anything we develop for government, the government gets to use for anything it likes forever. So we've effectively open sourced all of the work we've done for platforms, the work we're doing with Landsec, we've already said that results of that will get fed back into the hub. So we're trying to bring all these things together and create this sort of self-reinforcing ecosystem. And again, I think there's a really nice thing that started for MOJ then got picked up more centrally by the IPA. That influenced what happens in the hub. Private sector clients like Landsec are picking this up to feed it back in. So again, there's a nice kind of reinforcing circularity that public and private sector working together can scale this up and start to demonstrate enormous benefits. So it's our sort of contribution to this debate. We've never actually, as Bryden Wood, ever protected a system or put patents in place. We've always been very keen to publish what we're doing, again, because of that problem statement I referenced earlier. The 2 apps that we've done, we've open sourced the code. So again, we haven't tried to protect it. So again, if you go back to that problem statement, what can we all do to make the planet able to sustain 11.5 billion people? This is our contribution to that. And as I say, the more people join us on this journey, the bigger the benefits. I think one of the things that's held back our industry is this sort of secrecy and protectionist attitude. So lots of people are developing their own system in secret for their own benefits. And it means that people are only moving at the pace that they can move at on their own. As I said earlier, it's too slow for what we need to do. We think the only way the industry can cope is if everyone starts to contribute centrally, everyone builds on everyone else's work. If we have a much more open attitude and we start to shift our, in my view, daft ideas about IP, it's the only way we're going to do this is collectively. And so it started out as an initiative that we were driving, but we like to think that it's a movement now that more and more people will start to contribute, and collectively it will become the thing that transforms the sector.
Thanks, Jaimie.
Thanks for that. Thanks for listening. That was a really interesting conversation. I hope that's been of use. And look forward to talking to you again soon.
Next month, Jaimie will be talking about the practicalities of transforming construction. How do we turn the vision into reality? What are the steps, blockers, and so on? In the coming months, we'll also be joined by some esteemed guests and colleagues. Make sure you don't miss out. Until next month, thanks for joining us. Bye for now.
Thank you for listening to Built Environment Matters, a podcast brought to you by Bryden Wood. Listen and subscribe wherever you get your favourite podcast, and you can follow Bryden Wood on LinkedIn and Twitter.